Hi everyone, now we finish this summary sheet, we can start to answer some questions, past paper questions using this sheet. So let's have a go at this. So diamond has a giant covalent structure. I'm going to get out my handy highlighter. Giant covalent structure. State one property of diamond that is a result of its giant covalent structure. So I'm just going to look back here. I can have high melting point, high boiling point. So I'm just going to put high melting point. So I'm going to write out the whole word melting point, not MP, so that the examiner knows exactly what I'm talking about. So substance X is a gas at room temperature. So I'm going to highlight the word gas. It is a simple molecular covalent structure. So I'm going to highlight that. Which row of the table shows the properties that substance X is most likely to have? Okay, I'm going to go back here. Simple molecular, so properties, low melting point, low boiling point. Some are soluble in water. They don't conduct electricity. So let's have a look at that. So low melting point, low boiling point. So we're looking at boiling point low. So it can't be that one. It can't be that one because those are high. So it must be between those two. Solubility in water. It says some are soluble in water. So I am going to put, because it's some, I'm going to put low solubility in water. Okay. So that is A. The answer is A. Okay, question 3. Covalent substances can be simple molecular covalent or giant covalent. Ammonia is a simple molecular covalent substance, so simple molecular covalent. Okay, which is the most likely set of properties for ammonia? So melting point, remember we said simple molecular melting point is low, so we're looking for a low number. So it can't be that one and that one because that's high. So those ones are lower, and then a low boiling point. So if we look at these, the lowest one is that one, and it does not conduct or conduct electricity. Most don't conduct electricity, so it must be B. So you can see we're using our notes there to help us. Ammonia, NH3, is made by reacting nitrogen and hydrogen. Write the balanced equation for this reaction. Okay, so it's reacting nitrogen. I know nitrogen likes to go in pairs, that's N2, with hydrogen, and I know hydrogen goes around in pairs, it's H2, and it's told me the ammonia is NH3. So NH3, I just need to check there's the same number. There's 2 nitrogens here and only 1 there, so I'm going to have to put a 2 in front of here to make 2 nitrogens, and then 2 times 3 is 6. I need to make that 6. So 3 times 2 is 6. So there you go, it's balanced for me there. Okay. Magnesium oxide has a melting point of 2,852 degrees C. That's really high. Explain why magnesium oxide has such a high melting point. So I'm going to look at the things with high melting point. So I've got ionic has a high melting point. Giant covalent like diamond and graphite have, but it's not diamond or graphite, it's magnesium oxide, so it can't be that one. Metallic has a high melting point, but it's not metallic because that's just metal. So it must be ionic, which is a metal and non-metal. If I look at that, magnesium is a metal, oxide, yeah, it's a non-metal. So it is ionic bonding between magnesium and oxygen. Okay, I'm just going to check the mark scheme, make sure I'm getting everything right here. So, yep, and these are very strong ionic bonds. So it needs a lot of energy to separate the ions because it has high electrostatic attraction. And just to show I really know my stuff, I'm going to look at magnesium. If I find magnesium on here, it's in group 2, so it'll lose 2 electrons. Okay, so it'll form Mg2+, and that is a cation. And then we've got our oxygen. Here you go, it's in group 6, so it'll gain 2 electrons. So it'll have O2- anions. There we go, got all those key points, those key words in there. So next one, state 2 characteristic properties of metals. So I'm just going to look back on here. I could probably do this without it because I can just think of metals, but I've got high melting point and high boiling point. Insoluble in water, conduct electricity. We also know metals are shiny, they're ductile, which means you can pull most of them into wires. They are strong, they conduct heat, they are malleable, so you can change their shape, but I'm going to stick with these: high melting point, high boiling point. High boiling point. Okay, there we go. So, question 6. Figure 18 shows the ability of different substances to conduct electricity. So here we go. All these things. Explain these results by referring to the structures of the substances. Now, this is a 6 marker. And at the bottom, it shows you how you get into each level with your marking point. So basically, if you put some kind of simple information in, you get a level 1. If you start to link it and have cover several areas, you've got level 2, which is 3 to 4 marks. And if you look at this for level 3, 5 to 6 marks, you're supporting throughout by linkage and application of knowledge and understanding. Lines of reasoning are supported by sustained application of relevant information. Okay, so I'm just going to make sure I've got my mark scheme here to make sure I don't miss anything important. Okay, just give me 1 second. Right, so we're going to start with this. So calcium chloride. So calcium is a metal. I know it's a metal because it's over on this side of the periodic table here. And chloride, so chlorine is over there. So it's a metal and non-metal. And I know from here, my bonding that I have with metal and non-metal is ionic. So calcium chloride contains ions, which are charged particles. So solid calcium chloride, which is the first one, if I look on here with ionic, conducts electricity in water or solution as a liquid, but not as a solid. So it does not conduct electricity as the ions cannot move. They have strong, moving out of space, strong electrostatic attraction, and they form a lattice. So that's basically what we're saying. Here we've got a lattice structure. They don't conduct electricity as a solid, but they do as a liquid. So if we have a look on here, it says molten. Molten means liquid. So whereas molten calcium chloride, the ions can move. Okay, so let's have a look at diamond as the next one. So diamond is giant covalent, and they form a lattice, and they don't conduct electricity. So diamond, It's a giant covalent structure in a lattice. So all of the electrons are bonded and cannot move. So they're all in their electron pairs. So all of the electrons in the outside electron shell are bonded within the covalent bonds. They cannot move. So that's that one. Diamond, so it doesn't conduct electricity. So I'm going to take one off that. That one does. That one doesn't. That one doesn't. So zinc. Now I'm just looking at my periodic table. Zinc is found over here somewhere. Oh yes, it's here. So zinc is a metal, so it must have metallic bonding. So metals, metal ions plus anti-localized electrons, they conduct electricity in solid and liquid. So zinc says metallic structure with metal ions and delocalized electrons. They're free electrons, i.e. they're not kind of stuck where they are like they are with diamond. So free electrons which can move to conduct electricity. Okay, so we've done that, we've explained it. So it's explain these results referring to the structures. So it's saying why they can conduct electricity related to what the structure looks like. So we've got ions in there, we've got giant covalent structure. This one here, the calcium, molten calcium chloride, is because it's a liquid. And then zinc is metallic, so it has the delocalized electrons. So there you go. Thank you.